A tornado's winds can exceed 300 miles an hour, stronger than a hurricane, yet the whole thing can form and vanish within minutes, out of a storm that looked completely ordinary just half an hour earlier. Here's how. Tornadoes don't come from any ordinary thunderstorm. They almost always come from a specific, especially organized storm called a supercell, and the key ingredient that separates a supercell from a regular storm is wind shear, a change in wind speed and direction at different heights in the atmosphere. When winds close to the ground blow in a different direction, or at a different speed, than winds higher up, they create an invisible, horizontal tube of spinning air, rolling along like a rolling pin lying flat between two layers of the atmosphere. On its own, this rotating tube is harmless and invisible, lying flat and doing nothing dramatic. That changes when a powerful thunderstorm updraft, a column of rapidly rising, warm, moist air, happens to form directly above that horizontal spinning tube. The updraft's rising air catches part of that rotating tube and tilts it from horizontal to vertical, standing it upright inside the storm. Once vertical, this spinning column is called a mesocyclone, and it's now rotating within the storm itself, not just lying flat beneath it. As the mesocyclone tightens, similar to how a figure skater spins faster by pulling their arms in, the rotation can intensify dramatically, spinning faster as it narrows. At the same time, a region of sinking air called the rear flank downdraft wraps around the back of the mesocyclone, and where that cold downdraft meets the storm's warm inflow, it can help stretch and tighten the rotation even further, right at the point where a tornado is about to form. When the rotation becomes intense and narrow enough and reaches all the way down to the ground, it becomes a tornado. The visible funnel cloud people see isn't actually made of debris or wind alone. It's condensation. Water vapor condensing into visible droplets in the extremely low pressure at the tornado's core. The same basic process that forms ordinary clouds, just happening inside a violently spinning column of air. This is exactly why Tornado Alley in the central United States sees so many tornadoes. It's the one place on Earth where warm, moist air from the Gulf of Mexico regularly collides with cold, dry air sweeping down from Canada and the Rocky Mountains, creating the wind shear and instability supercells need over and over again through spring and early summer. Tornado strength is measured using the enhanced Fujita scale from EF0 up to EF5, based on the damage left behind rather than a direct wind speed measurement, since tornadoes are simply too small, fast, and unpredictable to measure wind speed inside them directly in most cases. A tornado isn't a separate weather event bolted onto a storm. It's the storm's own internal rotation, born from wind shear, stretched vertical by an updraft, and tightened until it reaches the ground. If you want to understand how the world's landscapes were really made, subscribe for more landform explainer videos.